Okay.
Now, so now hello to everyone and welcome to our first live talk organized by our IFIP working group on user interface engineering, the group 2.7, 13.4. And we intend to have bi-monthly webinars with group members and also with invited experts on topics around HCI engineering. And I'm very delighted to introduce our first invited guest. It's Celia Martini from University of Toulouse. She's an active member of our working group, and her talk focuses on educational aspects of HCI engineering. The talk will be about 20 minutes long, and then participants in this online meeting can ask questions. And there's also a live stream on YouTube. So Celia, now I hand over to you.
Good afternoon to everyone. My name is Celia Martini and I am Associate Professor in Computer Science at the University Toulouse 3 in France. So just a few words about my background before starting. My main research topics are methods, processes, techniques, and tools to design and develop interactive critical systems, such as aircraft cockpits in the aeronautical domain, or command and control applications for ground segments in the space domain. You can see here pictures of me at the European Space Operations Center, ESOC, in Darmstadt, Germany. Also in command and control room at the Guyana Space Center in Kourou, French Guiana, as well as in a prototype of autonomous car and in a Boeing aircraft simulator. So as you can see, in our research group, we always try to see the systems we are working on from the closest as we can. And on the teaching side, I have been teaching human-computer interaction for more than 10 years, and in particular, introduction to human-computer interaction, interactive system engineering, event programming, and task modeling. I teach at the bachelor's degree level, as well as at the master's degree level. Since 2017, I am responsible for the first year of the master in HCI at the University Toulouse 3. This master is a master in computer science dedicated to HCI, and the courses strongly focus on the design and development of software. I would like to use this last point as a transition to today's main topic of HCI engineering education. I have just been talking about the specificity of the master in HCI we have in Toulouse, but there are other academic curricula at the bachelor's degrees level and at the master's degree level that support HCI education all over the world, and each of them may focus on different aspects of HCI. This brings us to the notion of HCI curricula and to the elicitation of courses when building a curriculum. Several decades ago, in 1992, a report on HCI education curricula was sponsored by the SEM-CGI and prepared by a group of specialists. This report aimed to capture the concepts that were worth teaching. It provides a generic point of view on the diverse perspectives of human-computer interaction that may be taught. And these diverse perspectives are the human factors perspective, the computer science perspective, the development process perspectives, which includes design, evaluation, and implementation techniques and tools, and as well as the use and context perspective. So these perspectives are still relevant. There have been evolutions since the HCI curricular report went out. Users can now use a variety of devices to interact with different types of systems in addition to desktop applications. Users can interact on the move in different contexts. A lot of us have experienced the remote collaborative meetings or cocktails a few months ago during the pandemic. The evolutions are also on the development side, where programming languages are evolving and new programming languages are regularly released. Sorry. So do programming environments who evolve to follow the new technical capabilities. On this slide, you can see, for example, the Unity 3D development environment, which includes support to the development of new types of applications with augmented reality and virtual reality. This trend of constant change of context, devices, and techniques is well described in the article from Elizabeth Churchill, Anne Bowser, and Jennifer Priest. The title of this article is Teaching and Learning Human-Computer Interaction, Past, Present, and Future. And this article highlights the fact that HCI professionals, researchers, practitioners, and educators have to be progressionals to keep step with these constant evolutions of technologies, techniques, and contexts of use. This is the reason why the EduCAI community organizes the EduCAI Symposium since a couple of years. The idea is to discuss and build a living curriculum that would take into account the evolutions of HCI. Similar initiative is currently led by the IFIP Working Group on UI Engineering, who organized a couple of workshops on the specificities of teaching HCI engineering. And the aim of this initiative is to share educational resources as well as to build a roadmap for HCI engineering education. This space is very useful to discuss the specificities of HCI engineering education. This topic, HCI engineering education, is of interest to most members of the working group, and this is the reason why I chose it for this first UI engineering live talk. I will thus go to the point of today's talk and start with the specificity of HCI engineering education. HCI engineering education focuses on teaching how to design, develop, and implement interactive computing systems. The aim is to provide students with knowledge and competencies about systematic approaches, methods, and tools to make and deploy interactive systems that are usable and reliable. Amongst the engineering approaches that can be taught for the purpose of building usable and reliable interactive systems, models are very interesting because they enable to describe systematically a part or an aspect of an interactive system. There are different types of modeling techniques. Each of them targets the description of an aspect of an interactive system. For example, user task models, dialogue models, system models. And to be able to systematically describe an aspect of the interactive system, sorry, excuse me. What I wanted to say, yes, to be able to describe systematically an aspect of the interactive system, we have to be able to identify the core concepts about this aspect that we want to describe. And then once the models are produced, they can be used to analyze if the target property for the interactive system should be reached. For example, this slide shows a finite state machine model of the behavior of the activation of light bulbs for a desktop application that simulates the display of traffic lights. In this example, the activity of modeling before programming aims to teach how to systematically design the behavior of the user interface. This is a dialogue model, and moreover, the model supports the analysis of the reliability of the application. Generally, when teaching science, scientific modeling is the iterative and cyclic process of developing and using models in science, and the produced models aims at investigating, representing, explaining, and predicting phenomena. Models are central tools for communicating and reasoning in science, and modeling competence is emphasized in standards and curricula in many countries. I think that models are specifically important in HCI engineering education, especially because we target that our students are able to apply systematic approaches and to ensure properties for the interactive system they will develop and deploy. And HCI, excuse me, and HCI engineering requires to engineer software for the rendering, for the dialogue, for the input interaction, for example. And beyond arguing for the use of models in teaching HCI engineering, I even argue that not using models may be a problem. On this side, you can see an extract from the article of Leon Winslow about programming pedagogy. And it says, models are crucial to building understanding. Models of control, data structures, and data representation, program design, and problem domain are all important. If the instructor omits them, the students will make up their own models of dubious quality. If we don't teach modeling techniques to our students, they will themselves build their mental models of the different aspects of the interactive systems they are developing. They will also build their own mental models of how to deal with the different aspects of the interactive system, this without guidance. And all of these self-made mental models may be wrong. I thus think that providing the modeling competence and modeling techniques to the students is important. And if we take a closer look at the modeling competence, it is composed of three aspects. the meta-modeling knowledge, the modeling practice, and the modeling product. I will go in explaining the different parts of this modeling competence. So modeling practice is the specific sequences of observable and distinguishable operations while being engaged in modeling. Modeling practice can also be referred to as modeling process or modeling activities. It's simpler. Modeling practice includes data collection, such as gathering documentation, performing observation, or inquiries. A modeling product is a tangible, visible, and communicable artifact. Its quality relates to the components and relationships that are required to accurately explain the objects of the study. Its complexity relates to the number of components and relationships in the model. Meta-modeling knowledge corresponds to how models are used, why they are used, and what their strengths and limitations are. There are 5 aspects of the meta-modeling knowledge that can be learned. The first aspect is the nature of models and corresponds to knowing if a model replicates or envisions a part of the interactive system. The second aspect is named multiple models and corresponds to knowing different types of models and different foci of notations. The third aspect is the purpose of models and corresponds to knowing if a model aims to describe, explain, or predict. The fourth aspect is testing models and corresponds to the knowledge of how to test the model itself and how to compare the model with the analyzed part of the system. And at last, the fifth aspect is changing models and corresponds to the knowledge of how to correct a model, how to revise it due to new insights or due to wrong hypotheses. The meta-modeling aspect is the most difficult to acquire. A study was led a few years ago among students who had to produce a specification of a supervision application for the command and control room of an industrial mixing station. The students, around 200, had been taught different types of modeling techniques, including UML, P3nets, task modeling, and they could choose the techniques they want to design and specify their application. The aim of the study was to investigate if task modeling will be used and how, and in particular, if it will be used to understand user tasks and to identify the required user interactions with the system. It appeared that less than half of the students used task model and that the main reason they reported was that they didn't understand the benefits of using the models, even if these benefits had been discussed during the classes. This is an issue when teaching modeling techniques because though we know that students getting graduated reach an acceptable level of modeling practice and of building modeling products, so the two aspects of modeling competence, they may not apply them in their future practice and then fail to deliver usable and reliable interactive systems. I would like to discuss a couple of strategies. So I look at the time, yes, it's okay. I would like to discuss a couple of strategies to overcome this issue. Lecturers and professors who have faced this issue propose ideas, and these ideas may be interesting for HCI engineering education. These ideas are ensure that the modeling course ends up with a working application or service or app. The second idea is to show the usage of connected models from the beginning of the activity to the production of the application with appropriate tools. And the third idea is to develop pedagogical content knowledge. Concerning the first idea or strategy, we actually already have applied it. During last year's HCI Engineering Education Workshop at Interact 2022, we shared our experiences of teaching HCI engineering, and we had 2 examples of teaching material, 1 project, 1 exercise that are model-based and end up with a working app. Sorry. Second proposition is to show the usage of models that have a direct and concrete connection with the interactive application. In HCI engineering, and in particular in the EICS community, there are several contributions related to models that are connected to the interactive application. And this from a concrete software point of view. There is, for example, task model-driven generation of the user interface. There is also runtime interpreters of dialogue models running with high fidelity prototypes. And in this case, the dialogue model state is displayed close to the frame and close to the widget of the actually running app. And there is also a third way of doing this, which is the co-execution of task models with an interactive application. So this is a short video that I'm going to show you. This short video extract shows the example of a task model connected to a Java Swing application. The co-execution of the task model with the interactive application can be run in two ways. One way is to execute tasks step by step in the model, and the interactive input tasks described in the model will trigger events in the interactive application if the corresponding control is available and enabled. The video actually shows this way of co-executing the models connected to the application. There is a second way of co-executing, which is to execute the interactive application, and user interactions that happen will be tagged in the task model. There is a direct connection between the task model and the running application from a concrete software point of view. And using this type of technology, the students could run the application they developed and concretely see the tasks that are not doable by the user, either because something is missing in their application or because the required function is not available at the time it is needed by the user, and there is also an issue in the application in that case. The use of connected models could help to acquire meta-modeling knowledge, this by supporting the learning of how models are used. For example, in the previously presented video, compare tasks to perform with current state of the app. They would support also the learning of why they are used. For example, ensure effectiveness with developed app in the case also of the example I've shown you in the video, as well as their strengths and limitations. So meta-modeling would, this connected application would support the learning of the strengths and the limitation of the models that are produced. And in the example I've shown previously, user satisfaction, ensuring measuring user satisfaction is completely out of scope in this connection. And the use of connected models could also help to strengthen the modeling practice and product, this by supporting the co-evolution of models and application and checking consistency and correctness, and the identification of correspondences between elements in the models and elements in the application, which requires understanding the foundations of the modeling notation. Using connected models in our daily teaching practice requires several means. It would require an IDE, or maybe many IDEs, that embeds models, editor, and simulator, some toolkits to connect models to applications, know how to take into account the constant state of change of HCI and HCI engineering, and connected models to application, how to deal with new language, new technologies to continue to be able to make this connection, and also know how to take into account the diverse parts of views on the interactive system to be able to connect different types of models to the produced applications. So task models and system behavioral models, and maybe user models too. And the last strategy I would like to discuss is the use of pedagogical content knowledge. A pedagogical content knowledge is the anticipation of students' misconceptions and the knowledge of what teaching strategies are likely to be effective or not. Several examples of pedagogical content knowledge for HCI can be found in the article of Wiese et al. And this example is an extract from this article. The pedagogical content knowledge is composed of a problem and of a method to overcome the problem. The example of problem here is, in a previous semester, students didn't iterate on their prototypes enough because they schedule usability tests back to back. And the proposed method to overcome this problem is, as a course staff, we can prevent this by requiring separate deadlines for each test and revisions to the prototype in response. Another example of PCK that is related explicitly to modeling is about a recurrent problem I face personally when teaching task modeling to students. Each semester in task modeling courses, at least one student made a task model in a workflow-like way, rather than in a hierarchical way. And the proposed method to overcome the problem is to show explicitly to students a wrong model that has been produced in a workflow-like way. This in order to show them a result they should not reach. I think that it would be interesting to develop pedagogical content knowledge for teaching modeling, about teaching with and about models, and about also how to conduct modeling activities. Sorry. We could go towards a collection of pedagogical content knowledge for modeling and investigate whether there are some pedagogical content knowledge that are common to several modeling techniques and what PCK may dedicate to certain types of modeling. To conclude this talk, because I think it's time, I wanted to share with you my view on teaching modeling in HCI engineering education. And I think that we need to investigate how to support the acquisition of the modeling competence. Sorry. The main perspectives are to explore strategies to foster engagement of students and to increase the acquisition of meta-modeling knowledge. We also have to investigate what should be connected models for teaching HCI engineering. And then what are the relevant connections between types of models and running applications? And also, could we build teaching tools for connecting models to running apps? And at last, I think it would be worth working on pedagogical content knowledge for HCI engineering, education engineering, and for modeling, this in order to take into account meta-modeling, modeling practice, and modeling product. I thank you for your attention, and I'm ready to take questions and to discuss this topic with you.
Yeah, thank you very much, Silja, for your talk. Yeah, so now there is time for a couple of questions. So, and those people here in the meeting, you can either raise your hand or or make a sign, and then if you open your mic and your webcam, you will be also you will be visible also on YouTube, or you can ask your questions just using the chat function here. Yeah. Who has a question to Silja? Laura. Yeah.
Thank you, Anke. Celia, I have a question. I was thinking about one of the strategies that you presented. I don't remember who suggests a strategy. It's about tools going with modeling. And I was thinking, for example, when we are teaching, we taught automata on paper to understand how a widget is working, and we prepared for the structure of the program, but we don't use tools. And I don't think it's mandatory to use tools. So what is your point of view on this strategy that was proposed? Because I don't think we always use tools with the modeling approach that we have.
Yes, I agree that in the current practice of teaching, we not always use tools, but here the strategy comes from, so I can go back to this slide. Second one. Yes, this strategy comes from researcher who did some studies. It's in the discipline of software engineering in particular, and they have they have made the studies with their students. Quite a lot of number of students during 1 year, and I think maybe for 2 years in a row, and they indicated that. And the fact using tools foster engagement of the students and foster the comprehension of why the model is useful, and that it's beyond doing without tool, actually. So I think it's still important. So excuse me, I have something. Yeah.
Are you okay?
Yeah.
No, she's not okay.
No. It's the teachers have trouble with their voice, right? From too much talking. Yeah, but I think it's a good question. And I also wonder sometimes whether you should use tools which are developed for educational purposes, so which are maybe a bit simpler to learn to use. Yeah, if you use tools, or if you use, or whether you should use more professional tools, but it takes more time to use them.
Yeah, and also, you know, my experience, for example, I was a beyond automator. I was thinking when you use tools for describing task, I noticed that the students, they focus on the tool and the format instead of focusing on the meaning. And I really, in my course, I really don't care about how they will use the task tree afterwards. I mean, the key point was to force them to think about the user and what the user could do with the tools, with the project. And I found that it was sometimes it's maybe even it's a wrong effect, you know. It's they focus on the format and they forget to think about the content of the model, you know. The semantic of the model.
Yeah.
Yes, I understand your point. So excuse me, everyone.
Yeah.
No problem.
And I am allergic. So yes, I completely see your point of sometimes the student being distracted by the tools. But in that case, it was really the idea of having the model connected through the application that is running, then the application that they produced and that is running, so that they actually see when there are trouble between the application and the modeling they did, they actually see that it is simpler to investigate the issues that if they did no modeling at all. So I think the study was on this part, but I think it's very interesting your points, and that it would be interesting to have a study to compare these two aspects of are there more benefits on doing without tool or with tool? So they are more distracted or not, and what's
it also maybe depends on if I come back to the beginning of your talk, when you speak about competencies that you are trying to reach, I think if modeling is used as a tool for conveying some key concept and explain a process, user-centered process, maybe you don't need tools. On the other hand, you may need tools if you want to show that you can, from the modeling, go to the code and go to the application. So it's another goal. You know, I think you have two pedagogical goals, and it really depends how you will use models in your course. And I use model to convey some key concept and principle for designing and developing applications. But I think it's another goal to use tools to go towards the applications.
Yes, and that's why I think we should be together developing the pedagogical content knowledge about modeling, why modeling, and for what purpose, for what problem, and which type of modeling, and if we should use connected models or not. And it's really having a set of pedagogical content knowledge for modeling in HCI engineering education.
I think it could be interesting because there are several usage of models, modeling. I agree.
Are there more questions from other participants here? David, I think, do you have a question?
Yes, I would like to ask which is the barrier for people having a design background. So how people that have HCI engineering background that may work with model can bring the, let's say, design only knowledge into account?
Yeah, this is a very good question. That depending on the background. So for the talk, yes, I based my view on the educational path in computer science. So it's obviously easier for them this kind of public, but it's true that HCI engineering education, and I remember we discussed it at the workshop, should take into account different types of publics, and even people who are already practitioners in this industry, for example, or as you say, who are studying not computer science as their primary discipline. And I think it's also something that has to be investigating, and it's still coming back to the third point of developing pedagogical content knowledge. So I think modeling is still worth to be teaching to every kind of public, and so the articles I found that would describe the modeling competence and modeling knowledge, etc. It's more generic than only computer science. It's science in general, and even for public like children. So I think it's worth teaching models to every kind of public, but we have to find the right ones, and for the right exercises, and for the right skills that we want to make them acquire.
Yeah, I think in this context, it's also worth to think about how to relate models from different fields. So maybe the design-oriented students are more familiar with scenarios and such kind of models, and how can this be related to task models also, yeah? And if you see here an advantage, so then you might accept also this engineering approach, yeah? Or vice versa.
Exactly.
Yeah, there is maybe one brief question, yeah, and then before finishing this live talk today, is there one brief question? No more question. That's fine. So again, thank you very much, Celia, for being brave enough to give the first talk here in this series. And the next talk will be in about 2 months, as I said earlier, and the exact date and time will be announced later. But we already know our next guest. It's Jürgen Ziegler. He is a senior professor at the University of Duisburg-Essen in Germany, and his current research areas include recommender systems and also human AI communication. So stay tuned for our next live talk in about 2 months. Thank you to everyone for participating the live talk today.
Thank you. Thank you.
Thank
Bye.
you.
Thank you.
Thank you. Thank you.
You.